Okay, let's jump right into this explainer on AgentGuard. And honestly, why the way we secure AI agents needs an immediate ground-up upgrade. For a long time, our AI interactions have been pretty limited, right? We ask a question, we get an answer. But we are crossing a massive threshold right now. Agents aren't just answering questions anymore. They are taking actions. They're out there sending emails on our behalf, applying discounts, writing directly to our CRM systems. We're handing them the keys to our digital infrastructure. And with that incredible new power comes a whole new class of security risks that we absolutely have to tackle. Think about it like this. We're moving from the old risk of an LLM spitting out a bad sentence to the massive new risk of an AI agent executing a dangerous action. In the past, if a chatbot hallucinated, the worst-case scenario was usually just a clunky or maybe slightly embarrassing string of text. But today, the paradigm has completely flipped. If an autonomous agent gets confused or is maliciously manipulated, the result isn't just a bad word, it's a bad action. It could literally mean sending out highly sensitive data or modifying critical database records. The stakes have shifted overnight from reputational embarrassment to direct operational and financial ruin.
Section 1. The threat of action.
To really grasp the stakes here, I want you to picture a hypothetical sales deal desk assistant. Not a chatbot, but a fully functional agent that handles inbound leads autonomously, end to end. It checks inventory, calculates pricing, finalizes deals, the whole shebang. It's incredibly useful. But that exact autonomy introduces terrifying vulnerabilities. A targeted prompt injection could trick that agent into taking all your confidential customer data and leaking it externally. Or what if there's just a simple software bug? The agent might aggressively apply a 90% discount to every single inbound lead. And here's the scary truth. Traditional system prompts cannot stop this. You can write "don't leak data" in a prompt all day long, but the second the model is tricked, those instructions go right out the window. Section 2. Enter the behavioral firewall. If prompt engineering fails us at the language layer, we have to enforce security at the action layer. We have to stop worrying about securing the agent's words and start securing the tools the agent uses. That is exactly where AgentGuard comes in. It operates as a behavioral firewall sitting directly in front of every single tool the agent tries to call. It intercepts Liz calls before they execute. It evaluates the actions synchronously, in real time, blocking dangerous commands before they ever have a chance to touch your environment. And for context, this specific architecture is built on LangGraph and Gemini, which really highlights how modern frameworks can integrate these intense security checks right into an agent's natural workflow.
Section 3. The 5 guard layers.
Every single synchronous tool call has to survive a literal gauntlet to get executed. It's a multi-layered defense strategy designed to catch all sorts of failures. Every proposed action is evaluated through 5 distinct layers. It starts at L0, which is just a basic check. Is this tool even allowed for this agent? Then it flows through L1, L2, and L3, finally hitting L4, which applies side effect budgets. That essentially caps the blast radius. So if an agent does go rogue, L4 ensures it hits a hard limit before doing too much damage. Let's zoom in on those middle layers because they are fascinating. Layer 1 is dedicated to taint tracking. Once an agent reads untrusted data, like a sketchy incoming email, that data is officially flagged as tainted. L1 strictly prevents the agent from taking that tainted data and emailing it externally, stopping exfiltration dead in its tracks. Then you have Layer 2, which enforces hard business logic through preconditions. In our deal desk example, L2 ensures that absolutely no discount can be applied without a verified manager approval check. But what happens when an attacker tries something completely novel, something you didn't write a hard rule for? That brings us to the learned layer, Layer 3. The system uses statistical algorithms, specifically a Markov and Mahalanobis model, to monitor the agent's behavior. It understands what a normal task trajectory looks like. If the agent starts behaving in a fuzzy, anomalous way that deviates from the norm, Layer 3 flags it. It doesn't even need to know the specific exploit, it just knows the behavior is deeply suspicious and shuts it down.
Section 4. Observability through traces.
Stopping threats is critical, but if you don't know why your firewall blocked something, you're flying blind. You need total visibility into your system's nervous system. To get that, everything running through AgentGuard is deeply instrumented with open telemetry. That rich telemetry data is then continuously streamed to a self-hosted instance of Signos. This transforms every single autonomous decision, every block, and every pass into a fully queryable trace. You aren't just sifting through text logs, you are visually tracking the agent's exact thought process and execution path, down to the millisecond.
Section 5. The learning loop.
Okay, this is arguably the best part of the whole architecture. Its ability to constantly self-improve through a dynamic feedback loop. When Layer 3 catches a novel attack using those heavy statistical models, developers can go into signals and label that fuzzy anomaly. Once labeled, the system automatically promotes that attack pattern into a cheap, fast, deterministic rule that lives in Layer 2. So the guard literally learns and gets faster over time. What took heavy math to catch yesterday is caught instantly by a hard rule today. The creator of this architecture realized a fundamental truth. You absolutely cannot guard what you can't see. We tend to think of safety purely as putting up walls, but agent safety is fundamentally an observability problem. If you don't have deep, queryable traces of your agent's actions, you can't accurately write the rules to protect it. You have to shine a light on the behavior first.
By wiring a behavioral firewall directly into deep, open telemetry-based tracing, AgentGuard perfectly balances the incredible utility of agent autonomy with strict enterprise safety. It takes the black box of AI behavior and makes every single action visible, entirely explainable, and rigorously enforceable. As we wrap up this explainer, I want you to take a hard look at the architecture you're building right now and ask yourself a critical question. If your highly autonomous AI agent made a dangerous mistake today, would you even see it before the damage was done? Because if the answer is no, it is probably time to build a firewall.